Hello and welcome to part 2 of my little L system videos. In this video we're going to take a look at how we can start to visualize and interpret some of these strings that we generate. And for this I just modified the role set, so I still have the initiator of G, which in turn becomes F and then square bracket plus F and then end square bracket and F. And the F role becomes an FF. So to begin with, we need some kind of structure because this is going to be generating trees. And we need some kind of way to, excuse me, to hold these informations in some kind of a tree structure. So let's make a new struct for this, which we'll call a branch, because a tree consists of a number of branches and a branch consists of a number of points. So I'm going to call this points, which is going to be an array of transforms, because each branch can have several points. And each branch can also have several sub-branches. So we actually need something like a branches list also. So we need, if I just compile this, an array of branches. And if you type branch in here, you can see you cannot get create a struct which refers itself, so that's not really possible. So I'm just going to paint out real quick what we need to do here and what kind of situation we have. So we have some kind of a tree looking maybe something like this. And this can have, for example, a branch here, and it has maybe a branch here, and maybe this also have a sub branch, and this also has a sub branch again. So if this is a root up here, then what we need to do is to somehow be able to define that this is the main branch, and this is a sub branch, and let's pick a new color for this one. This is also a sub branch, and this is a sub branch, and this is also a sub branch. So you can clearly see that we need some way of defining this. And instead of using a tree structure, which we can't really use inside Unreal Engine, just out of the box, what we can do instead is to create an array of branches which refer to the parent branch. So if we look at the first branch, let's color this red, then it can have a pointer to its parent. So if I just color this gray, this is pointing back to its parent, and the first branch doesn't have a parent because it's the main branch, so it's pointing into nothing, or a -1 or whatever we come up with. Once we create the yellow branch or the green branch here, then we need to save a reference to the old branch here. So this one is going to be pointing to this one. And as we saw before, we're going to have a number of points for each of these. So the main branch has 1, 2, 3, 4, 5, including the first 6 points. So it's going to have 1, 2, 3, 4, 5, 6 points. And the green one here has 3 points in the array. And then this one is going to have, I think, obviously this is going to be pointing back to the green. So this is going to be pointing over here. And it has 2 points. So this is the kind of the structure we're going to be creating here. If we take a look at how this array is going to be looking, then it's actually going to be an array looking like this, where each of these cells in the array are going to be holding this information here. So the tree, this is actually the tree. It's going to be holding, in this case, 1, 2, 3, 4, 5 branches. So I'm not going to draw the rest of them, but imagine how they look. Yeah, fuck it. Let me just paint out this one, because this one is going to be pointing back to the red one. So this one is going to also be pointing back to this one here, and it's going to have 3 points. Okay, so I hope this makes a little bit sense how we're going to create this. So instead of this branches, we're going to have a pointer, which is going to be an index pointer, parent index, as an integer. So we save that, and inside the else system, we're going to create a new variable called tree, which is going to be an array. We're going to make this visible. An array of branches. So let's make a function here called generate tree, and let's start off by calling it, not here, oops. Okay, where did it go? Interesting. So generate tree, we'll call that after we have generated the else system. And we'll also call it in the construction script as well. So what this is going to do is to initialize this tree first here. So we're going to set this to begin with, make a new array of branches. So we're going to make a new branch. And inside this, we're going to set the parent index to for the first one to be -1, since we don't want it to point to anything meaningful. And the point, we're gonna add one default point here. So break this up, and actually what we can do here is to create everything like this. Not break. Make array. That's what we want. Oops. And we want to add 1 point. So as you can see, I already added what I called a turtle, and let me just delete this because I did this off video. If I just add a static mesh, it can basically be anything, but I just used a static mesh for this one. And call this the turtle. And I'm gonna move this turtle around in local space. So I'm gonna get the relative transform for this one, and I'm gonna add this to the array. And it just happens that the turtle is starting on at 0, 0, 0, so it's at the center of this actor here. So what we're doing here is we are adding 1 point to the points array, setting the parent index to -1, and then adding that into the array of branches. And then we have the list of in the L system instructions, which we are going to do the same as we did when we evolved it. So get array something, and we're going to promote this to a local variable, call this local current, just like we did before. This is basically the same. And then we're going to take the length, and actually we're gonna -1. Oops. And we're gonna do a for each on this one. No, a for loop. Going from 0 up to the length of this -1. So in here we're again gonna get the current character. So typing get for this index here, and then we're gonna do a switch again. Actually, let me just copy this from the other one. We don't have to write all of this stuff again. And according to the wiki here, it says that the G shouldn't do anything, while the F means draw forward, and minus means turn, and plus means turn the other way around, 25 degrees. So we're going to add a few things here. We're going to add a rotation on angle. And we're also going to add a length. And we're going to make them both visible. And the angle I'm going to set default to 25, and the length just to something like 20. So we can see that it moves a little bit. So the idea here is really to take our turtle and then instruct it to move in a direction. So since we're going to be moving this in local space, we want to get, I think it's called get relative rotation. There's nothing called local rotation, but for now let's just use this one. I can always tell that this is going to cause some problems, but we're going to go with this anyway to begin with. So get the forward vector, and then we're going to multiply this by the length that we want to move forward. Okay, so what we want to do with this is to set the new turtle location. So set we don't need to rotate here, so I'll just use this one to be here. And in order to add this point, because we are basically now adding points, that's the kind of the idea of this, that we want to add points to this current branch, is that we need to get the current branch. So we can get the current branch by taking the tree, and we can get the current by keeping track of the current branch. So we need a way of keeping that information. So let's call this the current branch index. Yeah. So obviously we need to set this to begin with to something initially. So we're going to set this to 0 because that's the first index. There you go. And this is basically going to give us this. So we can break this up here, and we want to add this point here to the array, and that point we want to add is the turtle's current position. So transform. So I can already say that this also has some problems, but we'll see that in a moment, because I think it kind of illustrates, it's best illustrated by looking at this in an example instead. So the G wasn't supposed to do anything, while the plus was supposed to turn. So we're gonna drag out the turtle again and say add relative rotation. So here is a funny thing, because we are doing rotations in local space, but this we have a add local rotation also. So we're going to take a look at this in a moment, but for now let's just use the add relative location. It's going to be more clear later on why this is going to cause some problems. So just bear with me for a little bit more. And for the minus, we are gonna subtract. So we don't have a subtract relative location, but rotation, so we're just gonna minus this one, or multiply it by -1. Okay, and the branching instruction is going to be where we add a new branch. So basically what we need to do is make exactly that. We need to make a new branch. And the current parent index is going to be this one. So this is pretty easy. And what we do here is we create a new branch and then we add it to the tree. So when we add it here, we also get a new index, and that's why the index comes in handy, because now we can set the new current index to be that index here. So now we updated that index to point to the newly added branch. So that's what we need to do when we meet the begin bracket. So we need to do a few things more. We need to create a new point, and that new point is going to be where the turtle currently is. So get the relative transform and make an array with that single point in it. So it's kind of the same as we did in the beginning. So let's make a comment for this. New branch. So this is the counterclockwise rotation. I think I didn't need a little bit more space for this. And this is rotation clockwise, and this is move forward. So all we need now is to implement the returning from a branch. So I'm gonna create a reroute node to begin with. Okay, so in order to get back again to the parent, we need to set the current branch index back to the parent index, and we can do that by getting we have it up here, getting the current branch, because inside that we have a pointer to our parent. So we can break this open. And here we have the parent index. So we need to set the current branch to be the parent index. And then we also need to set the turtle back to the first point of our current branch that we are in before we go back. So in order to do that, we can just get the first one here, and we need to do this before we change the branch, otherwise it's going to be a different, it's going to be, yeah, the wrong one. So here, oops, yeah, we are going to drag out the turtle again. So set the relative transform for the turtle. To be here. And then we return to the parent branch. So let's save this and compile. And right now we don't see anything yet. And that's kind of a problem because I promised that we will see something. So I'm gonna be adding some debug sphere here. So I'm gonna right click and say debug sphere. Set the radius to like 5 maybe. Set a different color. And a duration of, let's say, 10 seconds. So I connected this up to the move forward because that's where we move. And remember, we have the turtle location in relative space. So this location here is not going to be useful for us. So instead of that, we can get the turtle's world location by just dragging out here and get location, because actually both of these update whenever you update one. So if we compile this, we can now see two small spheres here. And I'm actually kind of wondering why we don't see more. Oh, I actually set relative location here. So actually what I need to do is add relative location. So now we can see it's starting to form this, what do you call it? It's, you can kind of see this is going to be a tree eventually. So if I type in maybe what would happen if I type in like minus f end bracket and then maybe an f and an f. Yeah, well, we can start to see something is happening here. So you kind of right now have to imagine that this is a tree going this way and then going to the side, and yeah, going to the side 2 times. And this is just 2 generations. So if I enter 3, you can see this goes on for, supposed to be going on for 3 generations. I don't really see my other branches. Huh. I wonder. Well, there's a bug in it. I can't really seem to figure out what it is. I'm pretty sure there's a bug. Oh, maybe not actually. Maybe not, because I don't have a G in here. So if I insert a G here, there we go. Okay, and maybe take this down to 3 generations and insert a G here as well. Whoops. Well, anyway, I hope you can see this is kind of starting to look like something. It doesn't really look like anything yet, but it will eventually be. This is kind of the basics for preparations for making the points that we need. So since we are doing all this in local space, it also means that if I rotate this up, you can see that the tree is actually following us. So since I'm currently just drawing out these debug spheres, just gonna wait for them to disappear. You can see that with this rotation here, it's a standing kind of thing. And it's still flat, so that's something that we will take a look at later on, once we have the spline meshes in place. But yeah, that's something for the next video, I guess. So thank you for watching, and be seeing you in the next. Bye bye.